I'll do 38. On 7-5, I'll do 38, and it's 2t squared plus 7t equals 4. So the algorithm says, first of all, you do what? You do any expansion that's necessary. Then the second step says you do what?
Get 0 by itself.
0 by itself. Do we have 0 by itself?
No.
What do we have to do?
Subtract 4.
We got to subtract 4. 2t squared plus 7t minus 4 equals 0. So now we got 0 by itself. The algorithm says next you do what? Common factor. Is there a common factor?
No.
All right. Now then, it's a trinomial. Is it a special case? No, because there's a negative sign right there. The 2 isn't squared. So it's going to factor by trial and error over the integers if it does anything. So what are we going to put? T and T. What are the signs going to be?
Opposite.
Opposite signs, plus and minus. Now, that 7 is going to be what, a sum or a difference?
The sum.
How many say it's going to be a sum? How many say it's going to be a difference? Ray and Caleb are right. Plus and minus, that 7 has got to be a difference. Right? Opposite signs, it's got to be a difference. So now what are we doing? We're doing integer factors of 2, integer factors of 4. What combination gives you a difference of 7?
Isn't it 1 and 2, 1 and 4?
Okay, 1 and 2 and 1 and 4. What goes with what?
The 4 and the 2 and the 1 and 1.
Okay, the 4 and the 2 and the 1 and the 1. 2 4 is 8. 1 and 1 is 1. Difference between 8 and 1 is 7. That's the way it's got to go. Now, 1 and 4, where do they go? Which one goes positive, which one goes negative?
Wouldn't the 4 be positive?
Because it's involved in the larger product, right? So the 4 goes here, the 1 goes there. Now where do these go? The 2 goes where?
The 2 goes to the positive.
So the 2 is going to be so that it goes 2 times 4. So it has to be here. Correct? Now what are we going to do? Use our product rule that says if you get the product of 2 factors equal to 0, one or the other of the factors has to equal 0. That's the bottom of your algorithm sheet. So that says that t equals minus 4, or 2t equals 1, t equals 1/2. And here are your solutions to that problem. Any questions? So let's look at 44. 44 says y times y minus 7 equals 18. Now your algorithm says what do you do first? Expand. Do you have to do expansion? Huh?
No. You have to get 0 by itself.
Okay, if you have to get 0 by itself, then you're going to do this. Now, my question is, what do you do next? You should have expanded first. You should have done this. Y squared minus 7y minus 18. You got to expand to someplace. Correct? Now then, once you get 0 by itself with the expansion, what are you going to do? Look for a common factor. Is there a common factor? It's a trinomial. Is it a special case? The 18 isn't a squared, right? Not a special case. Besides that, it's a negative. So now what are you going to try? Factoring by trial and error over the integer on a pair of binomials, right? Remember to put equals 0 out here. Now what are you going to put in the first position of your binomials? Okay. Caleb, I saw him mouth Y. Is that what you did? Okay. Y and Y. Now, what are the signs that I have? What are they? Positive, negative. How many say opposite signs? Positive, negative. Whenever you have a negative in that constant, it's positive, negative, isn't it? Plus and minus. Now then, is that 7 a sum or a difference? It's a difference because you're opposite signs, right? Now, what two numbers times itself is 18, whose difference is 7? Okay, 9 and 2, right? Which one goes where? This is negative. Where's the 9 go? Negative. Negative 9, positive 2. Now what do? Go down at the bottom of your algorithm and apply the principle. Y plus 2 equals 0. Y minus 9 equals 0. So Y has to equal negative 2 or Y equals 9. Let's do 54. It says Z minus 5 times Z plus 4. What do we do first? Algorithm says what first?
Expand.
Do we have to expand? Yep. So we're going to do what? On the left-hand side, we have to FOIL it, right? So it's Z squared. Outside is a plus 4Z. Inside minus 4Z, 5Z. And the last term's negative 20 equals 52. Now what are we going to do? We got to get 0 by itself, and we got to combine like terms, and we got to get it in descending order. Can we do all that at once? Which side would we get the 0 on? Which side would we take everything to? If we want our leading numerical coefficient to positive, we go left side, right, with everything. So we're going to have Z squared. These two are got Z's in them, so what do we have? Negative Z. 4Z minus 5Z is a negative Z. And then this minus 20, when that comes over, it comes over as a what? Negative 52. So what do we have? Negative 72 equals 0. So we got 0 by itself. Now, is there any common factors? No. It's a trinomial, not special case, so if it factors, it's going to factor by trial and error over the integers, right? In a pair of binomials, all of which equals 0. So in the first position we have what? Z and Z. What are our signs? Because that's negative, it's positive and negative. Now, this minus 1Z, that 1 Is that a difference or a sum? Difference. Two numbers times itself is 72, its difference is 1. Product 72, difference 1. Nine and 8 are 72, isn't it? So which one's going to be negative, the 9 or the 8? Because see, it's got to be negative there. The larger number's got to be negative, the smaller's got to be positive. Now you apply your principle, which says take each one of your factors and set it equal to 0. And z equals minus 8 or z equals 9. Okay. Do you see any of those that you may have trouble with? Anything? Okay. Now, I'm going to do word problems. 60 says the square of a positive number is 6 more than 5 times the positive number. Find the number. So what I want you to do is you're going to have a variable. And I'm just going to use x. What is that x going to be? Tell me what it's going to be. I don't want to know the value. I just want to know what in this problem does it say it has to be. It says it has to be a what? Positive number. So when you get done with the problem, this x has got to be a positive number. Okay, now it says the square of a positive number. So how would I write that? The positive number squared, right? And it says is. What does is mean? In mathematics, what do you write when you say is? Is equal to, right? Is says equal. Equals. 6 more than 5 times the positive number. So how are you going to write that mathematically? So, yeah. And it'd be plus the positive number, right? Which is x, right? So now, is that describing it? The square of a positive number is 6 more than 5 times the positive number. So now what we want to do is solve that, right? Well, first of all, gee, is there any expansion? I'm going down the algorithm. No expansion. Is 0 by itself. What am I going to do? Move everything left because I want the leading term to be, numerical coefficient to be positive. So it's x squared minus 5x plus 6 equals 0. Now, next thing is there a common factor? No common factor. It's a trinomial. Is it a special case? No special case. If it factors for solution, it's going to factor as a pair of binomials over the integers set equal to 0. Now, my first term is going to be what? X and x. Now, you notice I made a mistake. That 6 should be a what? It should be a negative 6. Now what are the signs going to be? So it's a positive and a negative. So the 5 has got to be what? A difference or something? What two numbers times itself is 6? It's a difference. What two numbers times itself is 6? Whose difference is 5? Okay, 1 and 6. Where do my 1 and 6 go? 6 is negative, 1 is positive, right? So now what do? I take my factors and apply the principle, set them equal to 0. This says x equals minus 1 or x equals 6. What's my solution to the problem? Well, x must be a what? What's it say on the top?
Positive.
So what's my solution?
6.
It can't be minus 1, it's got to be 6. That's why you identify your variable. You say this variable must be blah, whatever it is. Because you never know whether that's going to have to be necessary to identify which were your solutions or actual solutions to your problem. Okay, 62. So what I would want to see in this problem, I'd want to see that. I'd want to see that. Then, whatever you do, I want to see that. You can do any of those middle things, skipping steps, but these are the critical things that I want to see. I want to see what your solution is going to be in terms of words. I want to see what the problem says the variable's got to be. And then I want to see the answer. Or whatever else you want to put in there. If you think that it's necessary for it to do other stuff, so that I give you partial credit, if you would have given me this and made the mistake that I did, is put this as a positive, and then come down here and gotten a solution, which is pretty wild. Or you'd say there's no solution. Be plus or minus is what you'd have. Plus 2, you'd have minus 2, minus 3, which the solution is 2 and 3, which would have been wrong. And I would not have known that you made the mistake of transposing this from a positive on that side to a positive on this side. Then it'd be hard for me to, I would take 1 point off if you would have gone x squared minus 5x plus 6 equals 0, rather than doing this, and then got down to an x equals 2 or x equals 3 as a solution, I would take 1 point off. But if you would not have included this, and you'd have gone from here down to here, and I would not know how you'd have done it, then I would probably take 2 or 3 points off. Probably take 2. You understand what I'm saying? The more information you give me in a logical fashion, so I can follow it through, the better chance you're going to have to give partial credit. Because then I can see where you make the error. Does that make sense? Let's see. 62. It says the sum of two numbers is 6. The sum of the squares of two numbers is 20. Find the two numbers. So what are you going to do?
The sum of two numbers is 6. It'd be 3 plus 3.
Yeah, but the only thing is that might not be.
The sum of
Yeah.
the two numbers.
How are you going to set it up algebraically to find it?
Is it x plus x?
Okay, the sum of two numbers, so they're not identical, are they not? It says two numbers. You don't know what they are. So x,
It'd be 4.
one number, and y, second number, right?
You would have 1, 2, 7, 1.
Okay. So then what you do is you identified your two variables. They are two numbers. Does it say they're positive numbers? Does it say they're negative numbers? They just say they're numbers. Does it say they're rational numbers? Does it say they're real numbers? They're just numbers, right? Okay. Now then, it says the sum of two numbers are 6. If one number is x and the other number is y, how are you going to write it in algebraic form that the sum of those two is 6? X plus y equals 6, isn't it? Now it says the sum of the squares of the two numbers is 20, so what would you write there? in terms of these variables?
X squared plus y squared.
Okay, x squared plus y squared equals 20. So that's the information that you have from the problem, right? You have two numbers, x and y. The sum of them, x plus y is 6. The sum of their squares is 20. Now, you're not used to looking at problems with two variables in them. How could you get this as a single variable problem? It's involving using that first one and then substituting into the second.
34 and 2.
Okay, if you use the first equation and solved it for y, then it would be what? What if you got y by itself? What would it look like on the right hand side? You'd have to subtract x from both sides, right? So you go 6 minus x. Now then, you take into your second problem for y, you substitute this value. So you go x squared plus, and substitute 6 minus x for y. Now that equation is one equation, one unknown, right? One equation, one unknown. So we can solve that. So apply your algorithm to that particular equation. What is it the algorithm say you have to do first? Expand. Says you say expand. Is there something in there that needs expansion? It's a 6 minus x, right? It's quantity squared. Now, if you remember, when you have something that's a plus b or a minus b squared, just a plus b squared, it's always the first term squared plus 2 times the product of the first times the second plus the second term squared. And that's what I'm going to use those words to expand that problem. First term squared plus 2 times the product of the first times the second plus the second term squared. And I'm going to be thinking of this 6 minus x as this, as 6 plus a minus x, the quantity squared. 6 being first term, minus x being the second term. And I'm just going to use the words and convert it. So I have an x squared. Now then, plus the first term squared, what would I write? 6 squared plus 2 times the product of the first times the second plus the second term squared equals 20. If you memorize the words, and I'm telling you, in the rest of math, this math, college algebra, whatever it is, you're going to do that expansion so much that you are going to want to learn the words and be able to expand it fast. Because it's only going to be part of lots of things that you have to do to solve the problem. And if you have to put down 6 minus x to FOIL it every time, you will be not getting a test done, or not getting problems done. And you got to eliminate a lot of the steps that I'm doing. Here's 36 minus 12x plus x squared, right, equals 20. Now what are we going to have to do? Combine like terms, get 0 by itself, write it in descending order, leading term positive.
Write it in descending order.
Okay, descending order, leading term positive. So can I do all that at once? I'm going to bring that 20 over as a negative, right? So the first term is going to be what? there's two x squares, aren't there? The second term is going to be that minus 12x. Third term is going to be the 36 and bring this over as a negative, right? So what's it going to be? 16. Positive 16. I did it all at once, right? Now then, what am I going to do next? Common factor. What's the common factor? 2. What you could actually do is divide 2 into both sides, but I'll take the 2 out like this. Is that right? Okay, notice that I could divide both sides by 2 and that 2 could just go away. So it's x squared minus 6x plus 8 equals 0. That's a trinomial, not a special case. If it factors, it's going to factor as a pair of binomials. It's going to be x and x. What's the sign's going to be? This is same sign. Which sign? Negative sign. Both negatives. Now then, that's saying what two numbers times itself is 8, whose sum is 6. Okay, 4 and 2, right? Now we apply the principle. This says x equals 4, x equals 2. So what's my answer going to be?
12.
Okay, this is the way it works out. If you say x is 2, and you put x is 2 in this problem, what's y got to be? 4. So that's 4. If you say x is 4, and you put 4 in this problem, what's y got to be? 2, right? One number is 4 and the other number is 2. Call it x, call it y, call it what you want, right? 2 and 4 are the answers to the problem. (64). It says the sum of squares of 2 consecutive positive integers is 41. Find the 2 integers. So how are we going to write it down? How would we identify whatever variables we got? I'll put x is a positive integer, right? When it says 2 consecutive positive integers, if x is one of the integers, what's the next integer? You could put y, well, if it were what?
Isn't it like when it's consecutive, doesn't it mean like the same?
It's consecutive. So what would it have? What would be a consecutive? If 3 was an integer and the next consecutive integer would be 4. If it was 2, it would be 3, right? So how'd you figure out what it was? If x is the integer, then what's the next consecutive one? X plus 1, isn't it? So we're not saying that this is the next consecutive integer, right? You could go x minus 1. That would be a consecutive. X minus 1, x, they would be consecutives, right? You could do x plus 1 and x plus 2, they're consecutives. The easiest one is x and x plus 1. You could go x and y, and then say x minus y is 1, and you'd still end up with this kind of a thing. The next consecutive positive integer. Now, notice it might be important that we say it's positive, because the answer might end up with one answer is negative and one's positive. And it's saying, what are the two consecutive positive integers? Now, read back in the problem. The sum of the squares of two consecutive positive integers is 41. How am I going to write that? Okay, it says the squares, so x squared, right, plus x plus 1 squared has to equal 41. That's what it says, right? X is a positive integer, x plus 1 is the next consecutive positive integer, and the sum of the squares is x squared plus x plus 1 squared. So do we have to do some expansion? X plus 1 has got to be squared. This is x squared, and then it's going to be plus, won't change the sign, so it's what? First term squared, plus 2 times the product of the first times the second, 2x, plus the second term squared, 1 equals 41. That's exactly how fast you got to do it. You got to learn to do it that quickly. Then you're going to do what? 2x squared, going to get 0 by itself, combine like terms, plus 2x, move the 41 over as a negative, minus 40, right?
You just subtracted the 1.
I added the 1. 41 came over as a negative, and then it's a plus 1, so it's minus 41 plus 1 is 40, negative. I mean, in order to do it quick, you're going to have to do it that way in your head. Otherwise, if you get 20 problems and they're all expansions, and if you start having to FOIL all this stuff, you got to practice it. Now, notice it's descending order, leading term positive. There's a common factor. I can simply divide out a 2. Right? Now, two numbers. This is going to be x plus and x minus, right? Two numbers times itself is 20, whose difference is 1 is what? 4 and 5, and the 5 has to be positive, right? 4 has got to be negative. Now apply the principle. This says x equals minus 5. X equals 4. So which one of those fits the criteria? X is a positive integer. That'd have to be 4. And the next consecutive positive integer would have to be 5, right? So your answer would be 4 is the number, 5 is this number. And notice when you square 4, you get 16. When you square 5, you get 25. And the sum of those two is 41. It works out. All right.